Sean Hurley. We just want to welcome you to the community conversation. Today, we're going to be talking about planning Dynamo graphs. As I said, I'm Sean Hurley. I'm a technologist. I'm a community engagement manager on the team, and joining you from Northeastern Oregon today. So introduce the rest of the gentlemen here. Go ahead, Jacob.
My name's Jacob Small. I'm a designated support specialist focusing on generative design and BIM, based out of Boston, Massachusetts. Sol?
And hello, everyone. My name is Sol. I'm the product manager for Dynamo. So I'm the person you can yell at. You've heard my spiel before if you've been to any of these, but always approachable. If you want to reach out to me, please feel free to reach out via Twitter or the forums or so on. Always like talking to people about Dynamo.
Sol, nobody yells at you. You're too nice of a guy, and there's a lot of things going on, and everybody's got a punch list of what they want to get done. You know, it's those nice things. So, exactly. All right, before we begin, we got some rules. The line is muted to reduce the background noise. We invite you to turn on your cameras, just kind of we get a sense of who's in the room with us, kind of a sense of being in the same space. If you have a question, feel free to ask it by using the little icons at the bottom of the little hand, or ask it in the chat window. We can take you off mute as needed. There'll also be Q&A at the end. The session is recorded and a link will be emailed to you at the end. So it also goes up on YouTube. Next, please. Lawyers ask us to mention that if you make any decisions purchasing our products, that you make it solely based on the product in the state that it is right now, not in any forward-looking things. Like when Sol talks about you don't have to do anything anymore other than blink at the screen and the Dynamo graph fills in. Don't buy based on that. Dude, only on the existing feature set of the product. Next, please. Community conversations provide opportunities for engineers, designers, artists, and makers to meet in a safe, live, virtual setting, to share expertise, get to know leaders in your field, and grow your community network. This is a community, it's a conversation. Let's kind of have it at that, you know, talk, connect, network, get to know people. The sessions are always supported by Autodesk community managers to help guide conversation, feed important insights back from the community to Autodesk and the other way as well, and support participants in getting connected to the expertise you need. So with that, let's go.
All right, so welcome everyone. Today, this is the 12th installation in our Dynamo Office Hours series. So if you're joining for the first time, please do go and check out some of the previous things that we discussed. We have some really awesome talking points in the previous 12 or previous 11. And today we're going to talk about how to plan a Dynamo graph. So specifically, we're going to go around a 15 to 20-minute presentation. We've got a lot of slides for this one, so it might be a little bit longer. And then we're going to do a bit of a live demonstration before we jump into a Q&A at the end. But do feel free to put your questions in the chat throughout the entirety of the series. Cool. So in terms of planning a graph, we're talking about preparing in this way, kind of like a treasure map, right? You need to know where you want to go to be able to get there effectively. So planning in the context of Dynamo is super, super useful. So when it comes to planning, you can plan around your graph either from the start or the end or both sides. So if you're just searching for a keyword and you're like, I know I want to do something, let's say Revit walls, and you can start playing with some Revit wall nodes, you can actually build your graph out from that center point. But it's really good to have a start point, even if it's technically the end of your graph. So planning is a thought experiment, which means you start thinking about all of the potential problems that you run into before you even get to them. So, you know, when you think about what could go wrong, you can start mitigating what can go wrong at the outset. And otherwise as well, it's also much quicker in your head when you start thinking about these things than it is in reality when you're trying to build these graphs or use any piece of software for that matter. And also graph production is a journey. So it's going to take time and you need to understand your pathway to get there. So this is subservient to the first slide in many ways, but you need to kind of know the essence of your journey in advance. You don't need to know everything, but you need to understand the basic rules of thumb of, you know, where you start, where you end, and how you're going to get there. So in this case, the analogy of a map is relatively useful. You might know that you want to travel from Boston down through DC to get to Florida, but you don't need to know every single step of the way. You just want to understand some of those salient major points in your journey. And so jumping in to a graph without planning and following a node leads to many tangents and dead ends you may not need, which are awesome. So like I think playtime is awesome inside of Dynamo, and any thing in life, just learning and following your nose and seeing what can happen. But it is also not necessarily efficient. So if you're looking to get a task done, planning is way more effective than jumping in and just trying to figure it out on the fly. And so in terms about the process of graph planning, we talk about knowing how to get to your destination. So there's some sort of conceptual thematic things when it comes to Dynamo itself. And one of those to bear in mind is that nodes and graphs are thematically the same. So if you take the concept of a node, you have a series of different inputs, you have all of the functions in the center of that node doing things, and then you have an output, and a graph is basically the same kind of thing. So if you know what your inputs are, you know what your outputs are, then you can pretty quickly understand what functions you need to be able to translate those inputs into the outputs that you desire. So if you look at the second bullet point down here, we're talking about roughly input, function, output, or conceptually also data in, data manipulated, and data out. So a graph's logic here also parallels the inner workings of things like buttons in host applications like Revit or Civil3D or Format. So every single time you press a button inside of the context of software, it's going to do something. And usually you're going to have to input some data for it to do that thing as well. So you can conceptually think of graphs in exactly the same way as buttons. And you can conceptually think of graphs also in exactly the same way as nodes. And so if you start to think beyond the task and dream about required interactions, it also helps you frame how you're going to start building that graph and how you're going to plan for that graph too. So if you want to have the end result of your graph being an output in Dynamo Player, there might be different interventions you make when you build that graph comparative to running it inside of Dynamo itself. So things like feedback loops, when information comes back, how you inform the end user of what you're trying to achieve. These are all kind of salient points when it comes to figuring out how to effectively build your graph, and ditto for things like generative design. Cool. On to you, Jacob.
All right. So the big thing with graphs, when it comes time to planning, there's really two different methods. The first method that we're going to get into is kind of a listed sequence. And if you've ever been on the Dynamo forum and you've seen me reply with just a list of bullets or a numbered list or something like that, I've effectively provided this type of map for somebody else to sort of build through. And it can be really, really, really helpful. So the way I think of it, it's almost like a shopping list, right? What are the things that we're going to need in order to make the meal, right? If we've got in one of the demos we're going to get to today, I want to make some framing. I've got this kind of a mass. What are the steps that I have to sort of go through to get there, right? So we're looking for our ingredients, also any other reminders. Now the order also matters to some extent. You can imagine if you're going to go grocery shopping, you probably don't want to have to zigzag back and forth, run to the frozen food section, go back over to produce, over to the meat department, and then back to the frozen food section and back to produce, right? Super inefficient. So try and keep stuff in an order. Remember, you can always sort of move stuff around or put new numbers in as needed, copy paste as your friend there. And then you can also always refer back to something else by just referring to what that number was. So this first example that we're going to go over, it's how to build parametric windows on a wall. So the first thing that we're going to need is we're going to need to get the building mass. That's going to basically inform us where we could place our windows, right? But building masses are going to include groups and everything else. So we want to, after we get that mass, filter it down so we have just the surfaces that we're going to put our walls on, our windows on. From there, we can start to set up some sort of coordinate systems all throughout each one of those walls. If you didn't catch the section on geometry previously, we talked about coordinate systems in that, so you can go back and catch that in the YouTube playlist that was pasted in before. Beyond that, we can also, from there, start to look at sort of when we place those, how would we want to place those so that there's some degree of parametric control on both the U and V parameters. After that, we can start to scale this up on the X and Y axis, and that will allow us to sort of deform the shape of the window, the size of each individual window. We can then take and build a base window shape. In this case, we're going to do a 1x1 rectangle, and then apply that window shape to all the different scaled coordinate systems, and then we'll have windows on our walls, and then use the base surface that the windows are placed on to sort of trim out the window curves, measure the window to wall ratio, and then record out the results. So this is the overall graph. I'm going to sort of break it down, give you guys sort of an individual screenshot of, what's happening at each one of these sort of big groups. So first up, we're going to get the building mass, right? In this case, you may be, selecting a mass element in Revit. You might be selecting a mass in Format or something else. But in this case, I didn't have one because we're doing this as a sandbox exercise. So I built one using a whole bunch of random numbers, which can be kind of fun. From there, we're going to filter down to just the wall surfaces, right? So imagine I've done my selection effort here. We'll pull out from the faces from the building topology, find what that face geometry is, find what the normal is, pull the z value of that normal, figure out, is that z value equal to 0? Because if the z value is 0, that means I'm looking at a vertical wall surface. Use that to filter out my graph. And then I've remembered that data because I wanted to be able to keep this as a static exercise to show you guys today. Then we're going to start to create our parametrically controlled coordinate systems on the surface. Note the list levels here is going to be really key. So we're taking our base surface, getting the U and V axis, finding out what, building isocurves on the U and V. So that's the curve right down at the base of the shape and right up the side of the shape. So I can figure out how long those are. We pull the length of those curves, build a range from 0 to that length, add 4, stepping by 12. And that's going to give us our U value on the U curve. And then for the other direction, we're going to take the ceiling of that value divided by my V spacing, which is an input, and then build a range from 0 to 1 with that many steps in between. I shift those indices by 1, drop the first 2 items so they don't put a window right on the start or end of my surface, and then use that to build my coordinate system. From there, we'll scale the coordinate systems down accordingly, again, using those inputs from before. So we'll transpose that list, flatten it, scale the coordinate system on the XY plane, using those inputs from before in terms of the X and Y amount, and then use that to deform our geometry from our base window shape here and apply those coordinates. We'll be opening this up in just a minute. So if it's a little bit confusing it now, hopefully we can get into it a little bit further. But from there, we're going to trim the surface by the windows. So I'm going to take all those deformed, scaled up surfaces that my windows were built as, build them into one surface using a surface by union node, and then take the difference. And that's going to give me my window, or my openings in my wall. I've now got that sort of piece done. We'll then measure the window to wall ratio right up at the top there to sort of get the key pieces there, and then record that value out in terms of, set it as an output here. Maybe you might want to write that into a parameter on the wall or something along those lines, or record it back into Revit, format, whatever your integration might be. In this case, I'm just going to display it. So let's have a quick look at this one in Dynamo. We're not going to go into it too much because everybody on Twitter wanted to see the framing. So we're going to concentrate a little bit more on that today. But you can see it here. So I'm going to go ahead and I'm going to click run. This is the piece that sort of built up that initial mass, but you can see I've got my mass here. I've filtered out that individual wall. So you can see I've got the long list of faces here. Pull that face, the surface geometry from each face, filter it by that z-axis value if it's equal to 0 or not, and then filter out that content. And so this is looking at just the included content, and that's how I got those 5 shapes for my building mass. Turn this preview off. And I'm going to start to just do some quick runs through here so we can start to see what the end results on these pieces are. So you can see I've got a lot of coordinate systems that's been produced by this, and this is generating all those coordinate systems on the face. Turn the preview off on this, and then we'll unfreeze this guy. This is going to allow us to scale those coordinate systems as before. So if you think back to what the size of each one of those coordinate systems were previously, they were like really, really tiny dots, right? Now you can start to see we've got a little bit more shape to them, right? Because we've scaled them up on that X and Y axis. To move over to that next step, we're going to need to build our window shape, which I've done over here. So this builds a, helps if you click the freeze instead of the preview. This builds a single surface all the way down at the origin. You can kind of see it starting to show up right there. Right, and then we're going to pass that off onto the geometry transform node here. And there is all my windows. And now these are parametric in that if I change the width, or change the height, let's make it really tall. You can see that window got a little bit bigger when I made that kind of change, right? All right, so now from here, we'll turn this preview off, unfreeze this. Once again, we're going to union all of those individual surfaces that we had here into one single surface. and take the difference between that single surface and the larger set of surfaces. I'm going to turn the preview on for this guy. This step gets a little bit slow because it's doing a good amount of geometry rendering. Even slower when it's Zoom and it's a live demo, because live demos, that's how they work. So now you can see I've generated all those openings on that piece. And this could be good to use in Format. You could use this in Revit. You can use this whatever surface you, or whatever application you may want. From there, we can calculate the individual area of the windows themselves by taking the original poly surface, figuring out what the area of those is, and then do the math by just dividing the different surface, the remaining wall area, by that. It's summing it up and gets me a window wall ratio of 2.68. And then last but not least, we've got that record step. So if you were using this in Revit or something else, you might want to do something other than just display it with a color. Hopefully that made some sense. And we can talk about this a little bit more, but I do want to get to the structural framing. So
yeah, I want to add one thing when you get back to the slide deck. So conceptually, that was a lot when Jacob went through the graph. So even if you've got lost, all you really need to take away from this is Jacob listed out a set of steps. And so those set of steps correlate to the groups of nodes he has in his graph. So when he starts thinking about how to build a graph, he conceptually goes through it in his mind first and says, these are the steps I think I need. And then he gets into the Dynamo space and actually builds those steps. Now, it doesn't mean there's going to be a one-to-one relationship there. Maybe there's some things you missed. Maybe you need to do something else. It's totally fine. But at least you have this guidance, this directional guidance on how to get to an end result.
Yeah, exactly. It's not about, you know, when I started this graph, I didn't necessarily know how I was going to do each one of those steps either, but I was able to come back here and say, okay, you know, when it came time to the window wall ratio piece, well, how do I calculate window wall? I'll figure it out later. I know I have to do it, but I was able to sort of quickly put together just an area to say, okay, what are the pieces that kind of go to it? So you're going to start to scale that up individually and expand out on each one of these individual numbers as needed. Oftentimes I'll keep it like super vague first time out, and then really start to break stuff down if it gets really, really complex before I start even authoring in Dynamo. The other process that I use for this stuff is process diagram, right? Way I like to think about this is it's like the list, but with a CGI budget, right? Because it becomes much more visual than what you kind of had before. So this allows a great way to sort of see the relationship between different pieces of data, where data is coming from, where data isn't coming from. It can be quickly codified and standardized so that you can sort of share that content out, and is also expandable. Just like with our lists where it might have said just one thing, and then when we look back at that Dynamo graph, it's a bigger, longer list of everything that we're going to do. You can sort of take any individual piece and break it down into the sub processes that make up that larger box, right? It's also useful as sort of a project management tool, because you can start to break off individual chunks and say, hey, go work on this. You know, if I was partnering with Sol, can you go work on the piece that does the window to wall ratio calculation? I'll figure out how to sort of poke the holes in the surface, so on and so forth, and then combine stuff into custom nodes that you can sort of quickly bring back and forth and share together that way. Anything to add to that, Sol?
Nope, that's a lot. There's many different tools you can use for process diagramming. There's a bunch of free ones on the web as well. You can even use this inside of Dynamo just by using code blocks to mock up your flow of the graph as well. So it's a really interesting way to use code blocks, because then you can go and replace those code blocks with actual nodes as you go to build certain portions of your graph.
Yep. Cool. All right, so let's walk through a typical Dynamo process diagram. It always starts by kind of gathering the information that you're going to need. Oftentimes after I gather that data, I'm going to check to make sure I've got the actual stuff I want. Maybe I've gathered too much, maybe I've gathered too little, and you can sort of work that stuff through from there. From there, after I've checked, we'll start to do our initial calculations, right? So we're starting to deform our data. We're starting to run those functions and get new data. And then always check your data as you go. You don't necessarily have to have a formal checking process. It might be just quickly preview the geometry output or the data output, but that check step is pretty important. Do some more calculations as needed, some more checks as needed, and eventually get out to that record phase. We're going to sort of write out that end result back into Revit or Civil 3D, Format, or Excel, whatever it may be. And most graphs tend to follow this process, right? And Sol mentioned before early on that idea of we've got some inputs, we've got some sort of calculations that are done, some functions that we're going to run, and then we've got an output at the end. Our inputs are our gather, our output is the record, and the calculations are the functions in between. So if we wanted to lay out a whole bunch of framing, and from Twitter, I think this might be what everybody is here for. We've got a lot of framing that we want to sort of put together from this, and that could be a pretty complex process, right? I wouldn't want to just jump into Dynamo and start going, oh, well, I need some lines here, so on and so forth. It's not like traditional design where you can just put a pin on paper and get some results. So what would that process be? So we're starting over on the left. We want to end somewhere or end with what we've got over on the right. That blue arrow is the part that we really need to start to codify. So where do we begin? Well, start by getting the geometry that actually drives our framing elements. And if we think back to that larger shape, our rafters are running between these two lines that make up the edge of that surface. From there, all the rafters start to drive the location of the purlins, the columns, the braces, everything else. So that's really the first thing that we need to sort of lay out. So what I would do is I would identify the longer of those two parallel sides once I've grabbed them, find out how many spans we need to sort of make up all of those different rafters that we place by dividing the longer of those two spans by whatever my rafter spacing wants to be. And then I can create as many different points as I've calculated that I might need along the curves as I have spans, draw a line between each one of those corresponding sets of points, and then record the beam and location using the beam, or the beam by its location and a beam type, right? That's going to get me here, right? That's that first big step, is figuring out what all those parts of the process are. From there, we can start to look at, well, we want to put some purlins in, all right? So let's find the longest of all of my rafters, because that's going to control how many purlins I need. Find out how many purlins I need by just dividing the length by that purlin spacing, then create as many sort of evenly spaced points along each one of those curves as I have a need for purlins. Draw a polycurve by connecting all the dots along each individual piece, explode that polycurve, and then record out my purlins by location and beam type, right? So now I've got that sort of more complex grid set up there. This doesn't necessarily take into account elevations or anything like that yet. Probably would do that by just setting a rotation on my cross-section profile, but for now it's a good start. From there, we're going to find a point shortly before the end of each one of my rafter lines, project that point right down onto my grade level, and then draw a line from the grade point up to the top point. And then I can use that to drive my columns. So now I've got my columns done. We're most of the way through all of this framing that we have to create, and it's all just basically been this logic. And understanding what these steps are is really going to help us to sort of drive the actual graph. From here, we're going to start to draw a line between corresponding sets of points by finding a point offsetting from the start and end of each one of the rafters, and that's going to be where our brace eventually connects to. Then go up 3/4 of the way-ish, or maybe drop down from the top of each one of the columns to find another point. And then we can play connect the dots, right? We're going to connect the column point up to the rafter point, and then use that to record the brace by location and type. And that's going to get us the yellow lines, which are a little bit tough to see based on colors. We started to run out of stuff as we built that stuff through, but now we've got that entire graph. And the overall graph looks like this. And one thing that you can sort of point out, right? My key record points, highlighted in red down here, happen to correspond to points up there, as well as my initial gather point happens to correspond to the one big gather point off on the left there. And this is, again, pretty consistent for this idea of gather, calculate, record. Yes, I'm recording multiple times, but that still tends to hold true. So here's one last look at this longer piece, which we can sort of review. I'm going to jump into the live demo now. We're going to pop back over into Dynamo, and I'm going to open up the framing graph. Any questions in chat? Seems like there's a lot going on there and haven't been paying too much attention.
I think you're blowing minds here, Jacob. And there's a lot going on. You even got Thomas a little lost.
All right, we'll catch you up.
Yeah,
we'll catch you up, Thomas, here.
And there was a really good one. I just want to bring that one up. They were talking about the steps, on how you break it down on steps, you know, personal questions, for everybody. Do you try to skip steps, or do you try and break every step out and then consolidate later?
Yeah, I tend to hit the main points the first time out and then sort of flesh out where I'm going. So when I drew this piece the first time out, it was, you know, I've got geometry on one end, I've got beams on the other. What sort of steps have to happen in between? Well, before I've got all my beams and all the rest of the framing, the first thing I really need is my rafters. So now I've got two records, one for the two nodes, one for gathering the geometry, one for making the rafter, and then one for making everything else, because everything's going to be driven from those rafters. And then it was a matter of, you know, think through what that process is. A lot of times there's a sketch diagram that'll go along with this. Sadly, it was on a whiteboard and it's long lost to the Boston office, so I don't have it to share. But this is the actual graph. I'm going to go ahead and click run. So you can see the whole sort of process is being run here. This is the original sort of mass for the data. I'm going to go ahead and preview that so that we can see what that looks like. And I've got a few other ones here so that we can sort of see how this scales up. We'll just pop those over in after the fact. But we're going to basically work with stuff similar to before. I've set this up so that we can sort of preview that geometry so I can remember what the overall form looks like as I go. From here, I'm going to pull the faces from that topology, just like before. Those top topology nodes in our geometry library, again, are pretty well overlooked pretty often. So definitely keep those in mind, because often you can get to the content that you want very effectively that way. I'm going to pull our surface geometry, because really I can't figure out where those pieces are without first isolating those upper lines. Let me actually just turn off some of these other geometry previews so we can really focus in on what we're after here. So with this, you can see I've got each one of those pieces. What I need to do is I have to figure out which one of those surfaces is up at the top, right? The way I do that is I put a point at the midpoint of each surface using a point at parameter 0.5, pull the Z value from that, sort all of those surfaces by that Z value using this list sort by key. So you can see 0 is still at the bottom, but the second node was 30, and 30 is now all the way at the end, right? And then I take the last item, because that's going to be the item that's up on the top. And this is going to allow me to quickly get to just that roof, right? So you can see when I turn that on, that's the one piece of the geometry I can't see through. That's my upper roof. That's where we're going to do all of this actual framing. Turn this off. I'm then going to pull the perimeter curves from this roof. And I happen to know, because I know my design, that the nodes that I want are the curvy, or the lines I want to play connect the dots between are the curvy ones, right? I don't care about those end pieces. Those are actual lines. So I use this list dot remove if not. Wire in the type NURBS curve into here, and it's going to get rid of those two lines that make up the crazy outside edges. Now, if you had arcs instead, you could use arcs. You may want to just use some indexing if it's something that's a little bit less consistent. But in this case, I was trying to make something that would scale up to many different shapes of serpentine geometries like this. And that's going to get me to here. So if I turn that preview off, now you can see I've got just those two edges, and I've kind of done the job of selecting those two pieces. Oftentimes you'll find you can just use a select edge node if you're working in Dynamo for Revit. Might be a little bit more efficient than having to process all the geometry, but we're in a sandbox exercise today, so that wasn't really an option. So now I've got to build those rafters, right? If we think back to my process diagram, identify the longer of the two parallel sides. Well, curve.length will tell me what that length is, and then we can get the maximum item, and that's my longer length, right? Because that's really what I need. And from that length, I can then divide that by my rafter spacing. I set that at 4.25, round that down to the floor. So instead of getting this odd fraction, we're going to get a full number. And then I'm going to add 1. And the reason I add 1 is this is the number of rafter bays that I need, not the number of rafters. So we got to put 1 on the end there. That's going to get me a total of 60 rafters that I need. I'm then going to take my two curves and I'm going to reverse them, because I'm now at this point where I need to create points along those curves. I didn't note this piece because when I originally started building this graph, I didn't know I was going to have to do this. And that's one of those examples if we start to flesh this out as we go. So I reversed the last curve, don't reverse the first curve, and then use this point at equal chord length, which is going to give me all those numbers in between, right? So now I can start to play connect the dots, right? Only there's one issue. I don't have my endpoints or my start points. So I'll just pull the start point from each one of those and the endpoint, add the start points to the front of the list, add the endpoints to the end of the list, and then I'm going to transpose those nodes. The reason I transpose those nodes, we'll go ahead and we'll preview this one now instead. You can see I've got 124, and these are all the ones on the outside curve, and the next list is all the ones on that inside curve. So those are kind of backwards. We can't play connect the dots just yet. So we'll transpose those nodes, and when I do so, this group, I froze it instead of previewing it. I keep doing that. There we go. This group is that pair. This group is that pair. Anywhere I go throughout the entire list is going to give me a pair. And so now I can just do a quick line by best fit through points. And we've located all of the rafters on what's a pretty complex shape. All right, so now from there, we're going to take that line by points. We'll do our quick little fake record here because I'm not connected to Revit yet, but I do want to make sure I can remember where those are. So we're going to just color them red. Now let's go and we'll get our perlins, right? So we're going to take our original curves, pull the curve length just like before, right? So we've gotten to this point. Now we're going to work on the purlin string. So find the longest line drawn, figure out how many purlins I need by dividing the longer length by my purlin spacing. That's going to get me this number. Once again, come down to the floor. I'm going to add 2 to it this time because I need to create not just the number of spaces, but one at the end because I'm going to use parameterization. I didn't use parameterization here. I used at chord length because, as we know, with NURBS curves, parameters are not consistent distances between. But because I'm working with lines, I can use parameterization to make it a little bit easier. And you can see how that content sort of split up. There's all my first points, second points, third points, all the way along the entire list. So there's the first set of purlin points, second set of purlin points, third set of purlin points. Anywhere along that list, I can grab any number. Let's go to the 6th row of purlins, and it's going to run consistently. And then build that polycurve all the way through all of those points. It's starting to look pretty fun there. Pull out the individual curves, and then last but not least, record that out. And that's gotten us down here. So there's my blue lines running all the way through. We then bounce back over to here, and then it's again sort of building the columns. So to do the columns, we're going to find a point shortly before the end of each lines, right? We're going to do that by taking the curve length, subtracting from that overall curve length what my column offset wants to be, add to the front of this list of my column offset, so a single item, all of those individual items after it. So we've got the number 1 plus whatever the other number is. Pull the point at the segment length for each one of those. Gets me all of those points up there. Find the closest point on that. From that point, find the closest point on the XY plane, which is going to give me all my points down low. And then it's just a matter of playing connect the dots. And now I've built all my columns, and we can record those out. Those are going to be green, if I'm not mistaken. Yep. And now we're into rafters, right? And so this process of iterating over through each one of those pieces kind of goes and goes and goes. So that got me my columns. The next point, I've got to find a point somewhere up the length of the column. So we're going to take our column, which is back here, find the length, subtract whatever my column drop distance is from that length, and then find a point at that segment length. And that's going to give me all of those points. Right. And again, if I change that column drop distance on the graph again, you're going to see that distance changes every time I change that value. Right. But I also need a point that's based off my rafters. So if we follow this back, this is coming from all the way back at my rafters. And this is coming from all the way back at my rafters. And now I need to find a point shortly off the ends of each one of those. So once again, I take the length, I subtract from the length whatever that value is. I add the actual value for my rafter brace offset to the front of each one of those items. And then we do a point at segment length. And that's going to get me all those points. And now we can play connect the dots. And then finally, one last node to record that content out. Right now, obviously, this is just sort of that analytical location line. We're not truly making all that content yet because we've got to worry about the rotation of all these different elements. But that's further content. I could drive another sort of process diagram that would allow me to sort of know where that content wants to come from. And that's how I automate my framing. So let's do one thing I'd mentioned before. I've got a few other shapes so that we can sort of see this working at scale. So let's try a different form or another form, right? Whatever that is that I might want to run into it, I'm going to consistently be able to get that content to run through, which is really great. Makes this sort of scale up to whatever that shape might want to be. All right, so that's the end of the presentation stuff. I've put a lot of stuff out there for you guys today. Any questions? I see some smiles on the camera, which is good. I see some other people scratching their heads. So running the gamut of emotions from one end to the other, I guess. Could I run it on a Mobius strip? Yeah, I probably could, because the curves wouldn't necessarily care about the normal because I'm projecting the columns down. I don't have the code for a Mobius strip handy in Dynamo. I know there's a Dynamo forum post that goes over that stuff. Great question though, John. It's definitely doable. Oh, that's a good question from Christian. Sol, do you want to take that one?
Yeah, sure. So the question is, how often does everybody just play in Dynamo? Or is most of your experience work-based? For me personally, given that I'm the product manager, I do a lot of exploration that is task-based, but fun mostly. I know that back when I was in practice as an architect and as a BIM manager, and then subsequently a consultant, I was doing a lot of project-specific things. So that was play back at the office when I was doing my own things, but when I was working with clients, I would be very much, or working on projects, very much working to get a job done. But the play does inform your ability to build better graphs over time when you start to explore sort of the relationship between different nodes and how things function and behave. And one of the comments I wanted to make back on Jacob's sort of representation of how to do a process map is you can also do what's called like an MVP, which is like a minimum viable product. So this is like, get it working on one thing first, and then start to think through a bit of testing like Jacob did with other different input types or roof types. Just make sure that it starts working on those other ones as well. So if you have a script that you want to run across many different projects and you want it to work again and again and again, then you're going to have to build in some test cases to make sure that those edge cases, or those things that wouldn't be present in your first test case, that might be present in another test case, can get captured and covered.
Yeah, I do play quite a bit. A lot of times, even now, where people won't come to me and be like, "Hey, I need a graph that does that. Can you help me out?" I'll do that necessarily, and then once it's done, I'll do a save, and I'll spend a lot of time playing around. Like, what if I'd gone this direction instead, or what if I'd done that? Where does that get me? And I also tend to spend a couple nights a week actually just going through and seeing what I can do with Dynamo. What are the limitations of the geometry engine? How big can I make this go? That sort of stuff, and that you'll get a little bit more experience that way, right? It's just like any other tool. When you first started using Revit or Formit or Simple 3D or whatever it may be, early on, there's I've got to get the task done, but eventually you start to learn some by play as well.
Yeah, and I'd also like to add that like passion plays a part, right? So if you're passionate about doing something and you're curious, you're really excited about exploring the potentials of what you could do in a Dynamo script, then that's also going to bear out and pay fruits and dividends later in your work life.
Yep. Cool. There was another question in the chat. Maybe saying your name incorrectly. Wanted to figure out how I would check the normal. In that case, for for any individual points, we can come back and we can find surface.normal at parameter or at point. So I've got my original surface back here, sorry, back here. And now I can take any individual point and figure out what the normal is. So this is going to return the normal for every one of those beams, right? And with that vector, I can then figure out what the rotation is off the actual line direction to figure out what the rotation section has to be for the beam when it comes time to keep that beam from poking up through the roof, because nobody likes that. I might need to rotate by 180 too at some point.
Yeah. There's also a really good blog post actually from about like 5 years ago, 4 or 5 years ago on the side of the Dynamo blog that talks about taking a profile and lofting that profile across an undulating surface in a wall-based approach. It's actually really cool. I'd suggest you go and check it out. I can probably find a link and post it into the chat too. But it does explain, or start to explain about how to start using normals and how to start using translation and rotation pretty well. Yep. I also wanted to address Christopher's question around, generally speaking about an idea. If you don't have to know the entire node library to be able to go and process and map this out. You just need to know the kind of steps you're trying to achieve. So if you don't know the kind of node you're trying to do, in this case, you just say, I want to first of all, figure out what is the most important part of this particular graph on screen right now. And that is, picking the starting geometry, which in this case was the edges of that roof. So you can just say that. I just say, I need to pick the edges of the roof, as opposed to saying, I'm going to use the specific nodes or the specific approach to do that. Because once you start framing the kind of approach of what you need, that starts to formulate in the back of the mind the kind of things you might want to start searching for. So over time, through this aspect of play and over time through the aspect of building graphs and spending more time inside of Dynamo, you will naturally get to learn more about what the nodes are inside of the library anyway, especially if you partake inside of the forum. There's a lot of really cool things there. And I personally just like to go there and peruse, answer a few questions here and there, but also mostly just see what people are up to. And I learn a lot from that, from osmosis. And when I first started inside of the Dynamo space, I'd actually go and just recreate graphs that were posted on that forum, like 5 or 6 graphs a day. It's like, maybe half an hour's worth of work, but it actually educated me a lot onto why things were being done in certain ways. Because when you start to build those graphs and step through the data points of what they're doing, you start to understand the reasons why choices were made. And then that again informs when you start building graphs later down the line of how you could potentially approach that. Because like with anything in life, Dynamo has many different ways to solve a problem. There's many different angles you can take. The way Jacob's described on screen today is one of many, and every single incarnation, every single stepping stone. It doesn't mean it's always going to be that way. It doesn't mean that this is necessarily the best way. It's just a way to get it done in this particular context. So everything is a little nuanced, but it's also really cool to have it being nuanced because then that gives you freedom to start playing with it.
Yeah, it can be a little tough to sort of find stuff. Asking on the forum, I'm trying to figure out how to do this. Can be a little bit dicey. Some people do get a little, hey, this has been answered 100 times over. So try and do a little bit of research first. Sometimes we'll see the same question get asked 3 or 4 times in the same day, which, I'm at the point where I don't worry, I'll just post a link to the one that was asked earlier. But generally speaking, the community overall does tend to be pretty helpful. The other thing, if you go back and check the session on sort of how to find the node that you're looking for, we described different ways to sort of navigate the library. So in this case, if I was looking for the perimeter curves of a surface, right, we could search for surface and there's going to be some different stuff that comes up there, but I don't necessarily see perimeter curves. I might not know to search perimeter curves, but I can always go into the surface section in the library. And then you can see we've got our constructors. These will make a new surface. We've got our modifiers. This will change an existing surface. And then we've got our queries. This will get information about a particular surface. And perimeter curves is actually under modifiers right there. But it's not too bad. You're not really stuck sorting through every possible node in the world once you sort of understand the original object that you're working with, right? So once I isolated that particular surface, we were able to really narrow down what it was that we were able to, that we were searching through the library for.
There seems to be a lot of agreement in the chat around the same kind of thing, using search as an exploratory tool in many ways to leverage not just the names, but the descriptions and so on inside of the search space in the library. But yeah, I'd agree, Christopher, to the question on the forum of like, there's a lot of awesome data there, but sometimes it is hard to find. But a cursory check just for a couple of different keywords would probably get you breadcrumbs that allow you to find an answer. And if that answer doesn't solve your particular problem, then you can refer to that in your post when you request additional help. People are very, generally speaking, very welcome and willing to help questions that haven't been answered before. But like Jacob said, sometimes people's answer might be a little bit more gruff when it comes to please search the forum. So we have an off-topic question from Thomas. When do you expect Dynamo 3.0 to be released? Okay, so we can go down a long pathway on this one, but short answer, not anytime soon. And the reason for that is there's a bunch of different things that go into having like a major release. So we have Dynamo 2.0, we have Dynamo potentially 3.0, 4.0, 5.0 into the future. And we only make those kind of major releases for reasons. So Dynamo 2.0 had the switch from the XML file format to the JSON file format. And that was literally the reason to make that shift. So there's a bunch of other things that went into that release, but that was the reason why we made that major release. And by making that major release, it has the capacity, given the way that we build Dynamo with semantic versioning, to then break everything. So there was no promise that every single graph pre 2.0 would work entirely after 2.0. And so that's a major lift and a major cost on people using Dynamo. So we're very cautious about how often we release these major versions, and we only do it when it's really, really relevant to do so, because there's a bunch of sort of different tech debt and things that sort of aggregate over time that we would want to fix in a 3.0, but the cost of that is really high on the user. So what we're doing in the short term is we're actually doing a Dynamo visual refresh project. So this is going to be coming out next year, sort of in the earlier half of next year, which is going to be a massive modernization effort for how Dynamo looks and the paradigms and how it works, and we can find information, and an improvement to things like graph annotation capabilities and really, really cool stuff. I'll leave that as a little teaser, a little sneak peek. And so that is going to be it's 3.0-ish, but it's not technical 3.0. It's going to break stuff. It's just going to be improving the way that you interact with the model. If we were to also wrap that up with a 3.0 on the technical front, there would be costs associated with that.
The other thing about that is, it's breaking when you go to the 3.0, right? So it's just like we can't go 2.0 back, open a 2.0 graph back in 1.0. So we always try not to break things on people.
Yeah, so another thing is, like, I would honestly, and the whole Dynamo team would love to get to a place where we never have another breaking change. So our actual intention with when we do get to 3.0 is to try and figure out how we can make that the last time that we'd have to upgrade and potentially break things, and then move into a space where every single time we update, it's not going to make those kind of breaking changes. But that requires a lot of sort of careful planning and thought. So if you're worried about having to, breaking graphs, they're not going to break anytime soon. If you want to have all of these cool new features that would require breaking graphs, unfortunately, that's also not going to be anytime soon. But cool features are going to come out across the board that are not going to break your stuff.
Cool.
So do we have any other questions on what we saw today? Sorry, Jacob, to interrupt.
I was just going to say, Mark pointed out that he never thought to make a flowchart before. I actually hadn't either. The first time I wound up making one was I went and did a engagement on the other side of the world, actually, with an office that wanted to sort of tackle building a Dynamo graph in a group. And if you don't have something to sort of point at to say, this is the thing you're working on, this is the thing he's working on, that's the thing she's working on, this is the thing I'm working on, right? You guys go tackle that one. It's really tough to sort of divvy up the work. And that was the first time I'd done it, just because we needed something to point at. And I was like, wow, this like 1,000 times easier, because we all know kind of where we're going, and we're kind of moving in unison, as opposed to, if everybody just sat down and wrote a Dynamo graph, you're not necessarily going to get there. So it's a really good way to help divvy up the work and also plan for the future too.
It's maybe a little bit counterintuitive at the front because you're spending time to plan it before you actually do it, but you will save that time and more later on. So you spend a little bit of time up front to save a lot of time at the tail end. That's actually how we do all of the development on Dynamo ourselves within our teams, is we spend a lot of time planning. We spend less time coding than I guess you would expect coming from the outside, and more time planning, because it's more powerful for us, more effective for us to do the right thing than to be really good at doing the wrong thing. So we have to make sure that we're all aligned and going in the right direction when we build things, and think about it holistically, and think about the edge cases, and think about what could go wrong first before we get there, to start planning that from the outset.
Cool. All right. Well, we're just about at the end, so I think we'll start our wrap up.
Yeah, so we have more series coming up in the Dynamo office hours. So we have, next time we're going to start talking about extending Dynamo, which is talking about all of the cool ways you can play with extensions, one of which was demonstrated by John last time in the previous session. And then under that, we're going to look at under Dynamo's hood. So some of the sort of technical things that make up Dynamo that might be little gotchas or little things to unlock you, to free you up, to get you cooking with gas inside of Dynamo before we start talking about dinner with friends. So this is more of the sharing narrative, the sharing out, how you can have multiple people working in the same space, or how you can build some really cool thing and give it to somebody else to use later.
That was awesome, guys. Thank you. There's a lot to think about there. You know, what was going through my mind is the meme where the guy's drawing on a chalkboard, you know, all these mathematical functions and everything. And it's just like, pow, pow, pow. That was amazing. I would suggest maybe on YouTube, people to go half speed, maybe freeze frame. A lot of content, great information. I'm starting to figure out these things slowly but surely. But if you're, we're going to wrap this up with final 2 slides. If you're looking for other ways to connect and engage with the Autodesk community, we have a few resources for you. I muted myself. You can explore the various Autodesk communities, including the global network of user groups in the Autodesk Group Network, our industry-focused communities, helping our colleagues solve business challenges together, of course, the Autodesk forums, and staying connected with us on Twitter and Facebook. Next, that's it. Thank you. These will be recorded. You'll get an email link on this. And like Saul mentioned, you know, go back. There's 11 other great sessions leading up to this. I hope you find it very beneficial, and you'll join us again and recommend it to others. So thank you. Thank you, Kate, Rachel, everybody. Go get a cup of coffee or tea.
I need a refill. So
yes. Cheers, guys.
Thank you.
Or
a nap, Johan, maybe. All right, thanks everyone for coming. Appreciate it.